Hello and welcome to MindLift. In this video, we will discuss about the discrete probability distributions, binomial and Poisson distributions. These distributions are vital for analyzing situations where outcomes are discrete, meaning they take specific values rather than ranges. Binomial distribution. The binomial distribution helps calculate the probability of getting a fixed number of successes in a set number of independent trials. Each trial must meet the following conditions. Fixed number of trials. The experiment has a predetermined number of attempts. Two possible outcomes. Each trial results in either a success or a failure. Constant probability. The probability of success remains the same in every trial. Independent trials. The outcome of one trial does not affect the others. Example, flipping a coin. Suppose you flip a fair coin 5 times. Let the random variable represent the number of heads you get. Here, the total number of trials is 5. The probability of getting heads, success, is 50%. Possible values for the number of successes are 0, 1, 2, 3, 4, or 5. The probability of getting a specific number of successes is calculated by multiplying 3 components. The number of ways to choose successes from trials. This is called the combination, calculated by dividing the factorial of the total trials by the product of the factorial of successes and the factorial of the difference between the total trials and successes. The probability of success raised to the power of the number of successes. The probability of failure raised to the power of the number of failures. What is the probability of getting exactly 3 heads in 5 coin flips? The number of ways to choose 3 successes from 5 trials is 10. The probability of success raised to the power of 3 is 0.5 multiplied by itself 3 times. The probability of failure raised to the power of 2 is 0.5 multiplied by itself 2 times. The final probability is calculated by multiplying 10 with the results from the second and third steps. This equals approximately 0.3125 or 31%. Key properties: mean, expected value, the total number of trials multiplied by the probability of success. Variance, the total number of trials multiplied by the probability of success and the probability of failure. Poisson distribution. The Poisson distribution is used to model the number of events occurring in a fixed interval, such as time, space, or distance. Its key features include: events occur randomly. There is no fixed pattern for when the events happen. Events occur at a constant average rate. The mean number of events, called lambda, remains the same over similar intervals. No upper limit. The random variable can take any non-negative integer value. Example, calls to a call center. Suppose a call center receives an average of 10 calls per hour. The random variable represents the number of calls in a given hour. The probability of observing a specific number of events in an interval is calculated by raising the average rate lambda to the power of the number of events, multiplying this by the constant exponential term raised to the power of the negative average rate, dividing the result by the factorial of the number of events. What is the probability of receiving exactly 12 calls in 1 hour? The average rate is 10, and it is raised to the power of 12. The constant exponential term, approximately 2.718, is raised to the power of negative 10. The result is divided by the factorial of 12. After performing these calculations, the probability is approximately 0.094 or 9.4%. Key properties: mean, expected value, the average rate of events, variance equal to the mean. Key differences between binomial and Poisson distributions. Binomial deals with the number of successes in a fixed number of trials, while Poisson deals with the number of events in a fixed interval. Binomial requires the probability of success, while Poisson focuses only on the average rate of events. In binomial, trials are limited, whereas Poisson assumes an unlimited number of possible events. So that was all about binomial and Poisson distributions. See you in next video.